Now, so that's why we do length matching here, right? To avoid these problems. Okay. So firstly, we're going to note down what are the interfaces that we have to do the length matching. So the title will be the interfaces required length match. Okay. So again, what will be the first one? First is LPDDR4. Okay. Apart from LPDDR4, we have to length match. So again, wherever we have clock and command or control, command signal, that means our data lines or data byte groups are referenced to those, right? So because that's why these we can able to kind of run our hardware at very high frequency, right? Because we have some high frequency reference for that, right? So again, one will be eMMC. Apart from that, for HDMI, EDP, MIPI CSI DSI, eMMC, SDMMC, we needed length match between type C 0 and 1, and for MAC, right? And we needed kind of intra-pair length matching for USBs as well, right? So whenever we have like a differential pair, those differential pairs should be kind of length matched, right? So you can say USB 2.1 host, 2.0 hosts. So those needed intra-pair length match. Okay. That's it. So these are all the interfaces, almost all the interfaces that we have connected for high speed. Those all needed the length match there, right? Now, I'm just going to demonstrate the tool that is given by Altium Designer. Provided by Altium Designer, and it has different options and or different types of length match that you can try. And after that, I'll just note down few points, like you have to do that before go for the length matching, right? Otherwise you have to just delete all the things and keep doing that for days and all those stuff. So there will be like lot of effort from your end will be wasted, right? So after executing those points, then you can go for the length matching. So yeah, so for demonstrating that, I'm just going to add new PCB file on the same project, then later we'll delete that. Okay, perfect. So let's route a track here. So how many of you already did the length matching with Altium Designer? Anyone tried that? Okay. So this is the tool which is given here, and it has two options. Okay. One is interactive length matching, another is for differential pair length matching, right? So again, when we have to do the differential pair length matching, let's suppose positive part of the differential pair kind of required a length match. Okay. Its length is like either 5 mm or 3 or 4 mm less than the negative part, right? So then you can go for this one. So I'm just going to demonstrate both here. So let's see. Okay, so when I'll select that and press tab, or you can say the pause this section, you'll see on the properties section I'm getting few options here, right? One is the accordion, another is the trombone, another is sawtooth, right? So these are all three ways to kind of generate those serpentine, right? Whatever this thing or whatever these zigzag connection, we call those serpentine. Okay, and to route those serpentines, we have three options here, right? And all those options have some properties, right? Some measurements there, right? Either angle or this minimum joint, okay, whatever they call that, the tooth width, okay, the minimum height, actual height, all the stuff. So let's start with the first one, and here you can see two options. One is the amplitude, another is space. Okay, and for those, or the resolution of amplitude and space, we have this step. Okay, so again, step is not the problem for us, right? Step, we'll just leave it by default. Okay, we'll just go for 3 mil. We'll not discuss that. You know what are these steps? Like whenever we increase the amplitude, or whenever we'll play with the amplitude after doing the length match, the step of increasing and those will be 3 mil. Similarly for the this width of the serpentine, right? Let's discuss what will happen when we increase or decrease these two parameters. Okay, so by default it is 10 mil. Let's see what is that 10 mil is. So what you have to do, you have to select this. Okay, then you'll see this plus on your cursor position. You have to just go to the track and just hold the cursor and route it like this. Okay, now you'll see Control M, hold from here, go to this position and leave it. You can see this is I just increase from here, so this is not from exact center, and you can see this is almost 10 mil from center to center, right? And if I'll select that again, you'll see this is the amplitude, right? And that we have placed 10 mil here, right? Similarly, if we measure the spacing between those, so just go to the Control M one more time, click, hold on, Shift C, Control M. It is kind of okay. Let's leave it here, and you can see it is around 9.45 mil, right? It is like exactly same, right? So this is what spacing, and by varying these two parameters, we can able to control this you can say amplitude and this space, right? Now, what are these space parameter? Okay, so just go to that clearance point that we have discussed at the starting of this session. What are those clearance point? Those were the either 2 times or 3 times of the width, right? So same rule we have to apply here, because there can be interference between on the same line as well, right? Because these are coming closer, and at a time t barabar x second, or at particular time instance, you can see different voltages on these two lines, right? And there can be interference. To avoid that, we'll follow the same rule here as well. That's why they have given this space. And for amplitude, it is kind of, so whatever the space you have, and you don't want to route or this much section zigzag, what you can do, you have to, at the end you have to length match everything, right? So instead of routing this long section, what you can do, you can just reduce this and increase the amplitude, right? So this is again, now how you can change the spaces, by clicking plus, you can just increase that, right? After calculation, or you can directly enter the value here, and that will be your spacing, right? Now you'll see another option here, that is the meter. Like, what is the meaning of that? So by default it is 15%. If I'll do that 0%, what will happen? You can see these are sharp 90-degree turns, right? But when I'll increase, as this name suggests, right? So when I increase that, you'll see it is kind of more curvy, and when I'll go for 50%, you'll see these kind of sawtooth connections here, right? So for that, I would recommend just go for 15 to 20%, because see, when you increase that, you'll see our waveform is kind of shifting in this direction, right? So that means it needed more space to route higher value of these, right? So just go for 15, 20 or 25, like that, right? There's no standard for that, but again, obviously, like by experiment, it is proved for high speed signal, if you route 90-degree tracks, the impedance kind of vary, or I don't know, it is increased or decreased, but yeah, due to sharp turn, our impedance affects, right? So yeah, that is one thing. Apart from that, yeah, these are the properties that we can change for the accordion, right? Let's see the another one. So I'm just going to delete this, and yeah, let's again select this one, press tab. Another is trombone. Like what is that? So before I guess Altium Designer 21, I don't think this option was there on like Altium Designer 20 or 19. They have introduced this time, and the advantage of this trombone in length match, or you can say this feature is, or this pattern is, it just takes very less amount of space. So for example, I have very less amount of space and I have to just length match those. So you can see kind of we are routing just 3 tracks parallel, okay, and you can see like on a very small area we have routed so much length, right? Almost thrice the length, right? So like one is x, this is x, so this total length will be almost 3x, right? So this is one advantage of using that. And again, if you see the parameters, like what are these? So you can, yeah, I forgot one thing, I'll just show you later. Yeah, so from that here you can vary the radius, right? What will be the radius if I'll route like this? You will see the radius is varying between those. And again, these are the step, just leave it by default. Apart from that, it has different types. If you'll select the first one, you'll see it is again 90 degree, and you can like the first option, you can just vary the sharpness of the edges, right? Another is round, another is arc, right? So it has by default 30%, right? Or you can just, if you go for 50%, it will be round, right? So things are kind of related. And yeah, the same thing I just wanted to show you for the first one. If I'll delete that again, hold on, and just go for, sorry, select that, press tab, go to the accordion, and here you can see all these 3 options, right? So on this one, if you'll go for 50%, this will be again it will convert into the rounded. On rounded you can't change the sharpness, because it will be like again it will consider the radius instead of the space between the parallel, the serpentine, right? I hope you got my point. Let's discuss the another one. So press tab again and go to the sawtooth. So again, like as its name suggests, right, for sawtooth we have these many parameters that we can set. Like one is angle, another is the width of tooth, right? You want 10 mil this flatness at the top of the tooth, right? Or this is the spacing between the like there will be multiple tooths, right, on the track. So this is a kind of spacing between those, and from here you can define the minimum height, okay? And actual height is a kind of again so again when you define the minimum height and when you reduce that, you can't go below that, right? So I can demonstrate that as well. Let's route it quickly. Okay, so this is the actual height, which is 100 mil. If I low, you can see after 10 mil it will become 0, right? Okay, so that is one thing. Apart from that, if you want, you can change the width here. Let's go for 1 mm, right? And similarly you can play with the joint. So let's go for like 20 mil. You can see it's very let's go for 50. So you can see this increase, this distance will increase. Apart from that, yeah, so there are few more options. One is like single side. If you don't want to route on like other side or at the middle of this one, because that can be because of space constraint or anything. See, you can route only one side of either top or bottom of the track, right? Apart from that, for length matching, as you can see here, there is a small tooth that is different at different height as compared to other one, right? So you can remove that as well by clicking on this one. So it will just follow the fixed size of the track, fixed size of the height, right? So same will be kind of it's kind of maintain the uniformity. That's it. That is kind of not recommended, because our motive is to length match the track with the reference line, right? So again, that will be our priority. Apart from that, yeah, I mean, if you want, you can go for the fixed size as well. So these are the three options. And yeah, I mean, their use cases depends on the space we have for routing. If you have lot of space to route, you can just select one and length match all the tracks with the either from the accordion or trombone or sawtooth. Or if you have any problem, I would suggest like space constraint. You can try the trombone there and some of the accordion, right? So yeah, these are three options for length matching. So I'm just going to delete this one. Close, don't save. Okay.